Good afternoon, everybody, and welcome back to What's New in Solid Edge ST8. This is part 2. My name's Mark Fort from Edge PLM Software, and this afternoon we'll be following on from last week with enhanced welding, what's new in the welding environment, our enriched digital mock-up area in assembly. There's some quite exciting areas in assembly for us to look at. We'll be looking at our interface into the building information modeling area with our IFC files, and as usual, or as always, there's a great deal happening in draft, so we'll be having a look at what we've enhanced in the draft or drawing areas and our new drawing compare. Just a quick note on housekeeping. You'll notice that there's a questions box in your interface. If you want to ask a question, just type it in there, and as we get to the end we will attempt to answer that for you. So moving straight along into our welding area, we'll take a look at what's new in the welding environment in ST8. Solid Edge has streamlined the process of creating weld beads within an assembly by providing you with powerful tools to help you get your product to market faster. Let's take a look at the workstand and see where we need to place some welds. What has changed with ST8 is the ability to create welds from within the part environment. So what we're going to do is create a part in place. I've got a template here, which is a part template. I'm just going to create my weld on this face, and we'll give it a name. Okay, let's create a weld bead part between these two, between a couple of these faces here. The weld command within part is now under under sweep, the fillet weld. I'll select the rod there. We want to make that a 3mm weld. Accept that, and then I want to select that whole part there. Select that, and preview our weld. Again, I want to create a weld, a small weld, on these items here. So again, it's the same type of thing, except this time I want to have a 1mm weld. Select that part, and this one buried in here somewhere. That's that face set there, and we have our welds. The beauty of this is we have complete control over our colours and mass properties and what have you. Just let's change the colours here very quickly and return now to our top level assembly. What we see here now is we've welded this part, but if we zoom out a little bit, we'll see we've got similar welds required on these other brackets. It's the same bracket that's replicated through the assembly. Now with ST7 we provided the tool set to allow us to do that, a duplicate component. So let's select that. We want to create our weld part there. Accept that. We want to base it on this component, and then use all matching occurrences of that component to apply the welds. It's a little bit like magic when that happens. So there we've replicated our welds through our entire part. One of the advantages of creating our welds as parts is not only do we capture the weld nomenclature, we also select we can select the mass properties, we can select colours and what have you. It gives us a great deal more flexibility. Let's produce a drawing of this component and a section view through here, section cutting plane on here. Just a short one through there will be fine. And we need to have the section view itself off here, about here, and we can also, while we're at it, create a detail view of in here somewhere. That will be fine. About there. As I mentioned, we have the weld nomenclature applied to the part, so to retrieve that, all we need to do is to use our annotation tools for weld symbol, and on our weld symbol command bar we've got a tighter geometry, so it will pick the detail of the weld directly from the geometry. It makes it very effective. Let's pick off this weld here. There's a little 1mm weld in there. In here I think we've got a 3mm weld, and so on. It'll pull all those, it'll extract all that information. You only have to capture the data once. The other thing that we can do, of course, seeing we've got properties, is select create a parts list. But on this parts list we can detail our welds, and here's our fixture welds that we created. There's 4 of those. They weigh 0.2 of a kilogram each. We've got a total weight in there, because the resolution here is a bit low, but we've got a total cost. We can detail all of this sort of information, and of course everything's associative. If we go back to our original drawing and make a change, let's edit the welds here, this weld in particular. I think I remember that was it's a 3mm weld. Let's make that a 6mm weld. Save that, and return to our drawing. It says that we're out of date. Yes, of course we are, and let's update our views. There we go, and we can clear those instructions, but we see that weld has changed. Solid Edge with Synchronous Technology keeps you ahead of the game during your design and detailing processes by providing you with the best tools and technology to get your job done right the first time. Solid Edge continues to improve in areas which help our customers to achieve faster design times by providing state-of-the-art tools. Let's take a look at these advancements in the area of digital mock-up. Depending on the terrain, this robot may need a different kind of tread, so we can quickly change our focus to the area of the drive system. You can see the belts have already been added, but we also need to add a tread to the assembly. With this tread part we can use both the belt and an assembly sketch as our paths to follow along. Just applying a face-to-face relationship there, quite simple. We'll use the sketch next. New in ST8 is the ability to apply a path relationship, which allows you to set the origin but also create an offset, giving you full control of the placement of the part. And there's the centre for the top sketch. And here we're looking at the offset. I'll check the offset out. It's some arbitrary value. We'll just flip the direction so the offset's on screen, and let's change that to 500, and then back to 400. That's quite neat. In order for us to replicate the tread around the belt, we can use the pattern along a curve. Obviously this command offers several options to help you achieve the pattern you are looking for, but a new option within the command in ST8 is the ability to create a chord length pattern, which gives you the correct results when tracking a squared edge part around a curve without having to create any awkward construction geometry. Just me mucking around here trying to find the centre point. There we go, of the edge, and we can see that those parts have mated exactly to the belts. Let's replicate that on the other side, and there we go. So we need it on both sides. So we use the second curve path to offset the pattern. Again, having the right tools makes this type of work quick and easy. We mentioned digital mockup earlier, and the tools we've used so far to help us set this up. Because we want to synchronize the belts with the wheels, we can quickly set their driving variables to be equal. Notice here we will set the tread variable to drive wheels, which sets the value to 300. Then to simulate the treads rotating around the wheels, we need to set up a motor to drive these components. For ST8, we've added a new motor allowing us to drive variables from the variable table. When we run the command, we select the variable, give it a speed and a limit, and the variable table motor is created. You've seen how easy it is to drive components from the variable table, but let's take a look at another new capability offered to help you promote and use adjustable assemblies. As we change our focus to the top of the robot, you'll notice we've placed two of the same mini-arm sub-assemblies. Once made adjustable, we now have the option to override relationships, which basically moves the selected relationship to the top level assembly, giving us full control over these relationships. You'll notice both of them are available at the top level, those angular relationships. To better understand this, let's go back to the variable table where we can set up a quick formula to drive the same angle for each arm in different directions. Just looking for the name of the variable for the first arm, and we're going to put a formula in. We've got a formula called a variable called arm lift, which we'll use in our formula for the angle relationships. The first relationship is 90 degrees plus the arm lift value, and the second is 90 minus. So this means that they'll move in opposite directions. Once set up, we can easily change the arm lift value. I'll just move that down so you can see it. And you'll notice as I change the value that the arms will move in opposite direction. Powerful tools that provide the flexibility needed to get the job done right the first time. Now, using the new variable table motor command, we can also set these commands variables into motion. There's the variable motor command. We just pick up the variable, which is the arm lift, and apply a speed and a duration. And because it's an angle, the speed's in degrees per second. To better visualize these parts in motion, Simulate Motor command allows you to set up and run your animation using the motors we just defined. You'll also notice that the motors are defined within the assembly. Here's our two motor variables. Once we're in the timeline, many tools are provided to help you simulate your designs. For example, you can reverse the direction of the motors or simply apply a copy and mirror to get them to move in both directions. Then just click on play to see the results. Speed that up a little bit. As you can see, there's a great deal of processing going on behind the scenes, so it's not real-time speed that we get here. However, if you want the real-time speed displayed, we have a way of doing that. Let's take a look at the Save as Movie, and we can save that in either WMV or AVI format. Here are the results of these components being put into motion. I've added an angular component as well to the base of the arms. Being able to digitally mock up your designs within Solid Edge just got easier in ST8. Powerful tools and ease of use gives you everything you need to complete your designs faster and more accurately. Let's take a look at the Industry Foundation Class's file format for Solid Edge. In this assembly we have a range that was created by one of our customers, Lincat Limited from Italy. One of the reasons for using their dataset is because they're required to supply their customer with the IFC files. The reason for the IFC file format is it's a neutral format that can be used in BIM processes for construction processes. A typical workflow for our Solid Edge user might be to simplify the assembly before translating to protect the intellectual property. Then the architect using a BIM application such as Revit would place this IFC file into their building construction. To translate into the IFC format, we've pulled down the format here from our dialog box. We've got some options that we may want to set in here. For instance, we want to export our solids, only what's displayed, millimeters. The IFC versions, we've got 2 of those available. Say OK to that and go ahead and save. During the save process, Solid Edge provides feedback through this progress bar. With this range we could have simplified the entire product so it's just an outline, but the vendor may require more information. Now that we've translated our data out as IFC, we could reopen it, but in this case what I'm going to do is open a file that I just pulled off the internet. That one there. Just open that. It's an assembly. And you can see it being translated in quite quickly. And when we open it, we'll see the structure of the data. We've got a site and building, and we can get down into the story level, which is our building there. With all its components, and of course because we're in Solid Edge we can quite easily edit all this data. So the translator is both directions and is fully compliant with industry standards. I think for a lot of our customers this is going to be quite an exciting development. Solid Edge has always been uniquely powerful in capturing all aspects of your product design. With enhancements in ST8, this is no exception. Notice when we select a dimension, we have 3 different handles. This handle allows us to extend the dimension extension lines. Notice that the dimension is off-center, but when we start to drag it, it will snap into the center location, right there. With these handles, we can increase the gap around the dimension. Center handle allows us to quickly move a dimension, like this one here. We pick up the center handle there. Even though it's hidden behind there, we can move that down. If we insert a jog into dimensions, when we're taking it out, you'll notice it snaps to the non-jog position, which removes the jog. Here, all we need to do is move this dimension down and across. Diameter dimensions also have these handles. If we drag the dimension handle, this will just simply move the dimension. Dragging the handle on the brake will move the dimension side to side and extend the length of the brake without going to the properties. Notice that when we highlight all 3 of these dimensions, they share one common extension line. Moving the extension back not only moves the selected dimension, but moves the 2 extended lines at the same time. This is great. This dimension can stay it needs to move out, but this dimension can stay in the middle, and the arrows need to be flipped out. Notice we can do the flip. And again we can change the arrow head style. Watch this. Wow. Turning on and off extension lines has been improved, so no more property box for that one. Annotations have the same types of modifying handles as dimensions. Let's take a look. The centre handle on the finish symbol moves the symbol around. Midpoint handle flips the side of the symbol is located on, and the end handle extends the length of the brake line. Balloons work in the same way, but notice when we start moving the balloon we get this indicator to locate in 45-degree increments. Moving a brake, you'll get the indicator at the brake, and moving the brake itself displays the indicator at the arrowhead and brake line. Knowing the correct syntax or Unicode has been a challenge in the past with Solid Edge. With hole definitions, we can now add things like dual units without knowing what the syntax should be, or add rounding in a simple drop-down. Here we're rounding to 4 decimal places. On this dimension, we want to add some tolerance to the dimension with upper and lower limits. This dimension has a date. With the format command, we can choose from different ways to display this date. Notice how the day and the month are in lowercase. We have options to control this. Very nice. New to Solid Edge ST8 is the ability to have a parts list of a subassembly on the same sheet as the top level assembly, and the subassembly has its own unique item numbers and balloons. Just that quick and easy to have a parts list of a subassembly. Solid Edge has the ability to link reference text together, like here with these symbols. We change it to BB and we notice it changes down there. Solid Edge can also link to a callout with either a property text or a reference text, and when the symbol is changed it updates the callout. Let's see how that works. We want to change a datum frame, we pick up the source of that datum frame, the BB, and we insert it into the text. And when we change, everything updates. Very nice indeed. Next we'll add a new type of callout called technical requirements. Technical requirements are those special notes that we add to a drawing as a numbered list with numbers or Roman numerals to point out specific details about a drawing. I'm going to put in 3 lines of text here, and you see as I insert each one it puts a number alongside it, and we can change the numbering style into almost an infinite variables. And finally, well, the last one. Next we'll place this technical requirements text on the drawing, and we'll create a callout, and we'll link the callout to the technical requirements. We go down, find technical requirements in the list, pick out the one we want. Okay, I'm going to modify this note. See note 2. Very simple. Linking reference properties to the technical requirement is quick and easy. We do this to ensure that if the note changes, then the callout will also update, just like that. 2D drawings are a very important part of the design process. Solid Edge's uniquely powerful 2D drafting software continues to incorporate powerful tools to get the job done with amazing user experience. When working in a design team, there's times that someone could make design changes to a model file and never think about the manufacturing drawing. Then somebody opens a drawing and notices it's out of date. When this happens, there really isn't a good way to know what's been changed. Solid Edge ST8 has a tool called Drawing Compare. Let's see what's been changed in this model by comparing the two different draft files of the same model. Let's see how this works. We make some changes to the model, to the underlying model, and move the boss, and we'll move this face out a little bit. Now let's look at the drawing of this model. That'll need updating, of course. Update all the views, and there's been some changes. At this point we need to save the drawing, and I'll save it under a new name so that we don't overwrite the original drawing. Now let's compare these two drawings, and this is my favourite. Compare drawings under the Start menu. It's a new menu there, and we simply browse to the original file, open that. File 2 is our changed file, or our revision file, and we just press the compare button and it builds a compare file. We can save this and use it later, but right now we're just going to zoom in to an area and you see all three views update. The green, of course, is the original, and blue is the new file. We can see the changes there. We can zoom in and out, we can refit, we'll zoom up in another area. Just take a look at this back plate here. We can see the changes up in the top right, top left, sorry, and the original and the changes down in the bottom panes. We're going to save this compare. We can save this as a file name, and it's a BMP file, so we can open this later on to have a look at this without having to open the original files. Okay, get back into the drawing compare, and we can browse for that file that we just made. In fact, I think it's an earlier one I just opened then, and we can compare the changes. This is quite useful, and I think it's going to be a great tool. The Draw Compare tool is a quick and easy way to ensure our changes are the correct changes. Drawing and part model are up to date, and the changes are correct for our design. I think everybody will agree that this is going to be a very useful tool. Klaus Langer from Voith Hydro agrees that Drawing Compare in ST8 will be a real boon. Since Solid Edge ST7, Solid Edge has been uniquely integrated into the Microsoft Surface Pro. Full Solid Edge power and performance anywhere you choose to go. Solid Edge Mobile is available on all tablet platforms, Microsoft, Android and Apple, giving you view-only capabilities on almost any device. This recent innovation provides our users easy access to the growing range of Solid Edge applications. Let's take a look. Here's the website, and they're even available from Edge PLM software. Take a look. Don't forget Solid Edge's great user assistance, just waiting to show you both what and how. And the Learning Portal, which provides you with a full learning experience. The Solid Edge Community Live Feed. Let's just take a quick look. It's under the Community push button on your start screen and out to the internet, and there we are, logged into the community. Unread posts and comments, and you can even connect to Facebook from right inside Solid Edge. There are even instructive movies for you to watch during install. Edge PLM software runs a variety of training to suit your needs. Make an inquiry today. Once again, we've come to the end, and I thank you for your attention during this session. and I'll hand you over to the team for questions and answers. Once again, thank you for your attention.